Sigma notation. Now, were you Greek in
I
college?
thought you were, no.
Were you Greek?
No.
Me either. Okay.
I wasn't
Well, I
Greek
had
at any
something
point.
funny, but the only funny thing I was going to do is something with sig in the park, but I better not. Okay, so sigma notation. This is the Greek letter sigma, and it stands for?
Sum.
It always means sum. Not S-O-M-E. It's a sum, as in add up.
Like the math sum.
It always means add up, so sum.
All add 'em
So this would be ate some pie. Man, I'm funny today. All right. So here we go. We want to learn how to use sigma notation. So this means add up from k equals 1 to k equals 4 3 times k. So you're going to plug a 1 in for the k, then a 2 in for the k, then a 3 in for the k, then a 4 in for the k, and add them all up. Right. Is that okay?
Yeah, so we should have 4
Okay,
terms that we're going to
okay, I was being funny.
That was worse.
So what's 3 times 1? 3 plus, put a 2 in, what's 3 times 2?
6.
6. And then plug a 3 in, 3 times 3?
9.
9. And finally, this tells you where to end. Put a 4 in, 3 times 4, 12. Add them up, 18, 30.
There you go.
Happy?
Yeah.
All right,
Yeah.
go for
All
it.
right, so this one, we don't always have to start at 1 either. We can start at k equals 3 and go up to 7. I think,
My fault.
nice move. So I think we're still going to have 4 terms, but we're just going to plug in the 3 into k, and then we'll plug in 4, and then 5 into 6. So you got it?
Yeah, you talk, all right.
Okay, 3 squared plus 1 is 10. Got it, okay.
Yeah.
4 squared plus 1 is 17.
Uh-huh.
5 squared plus 1, 26. 6 squared plus 1, 37. And 7 squared plus 1, 50.
All right, and add them up, and you get a big number. Okay, there we go. Now let's go backwards. So this is the tricky part right here. How do you go backwards? So I want to take this and write it in sigma notation. Well, it looks to me like they're all even numbers. 2, 4, 6, 8, 10, and 12. And this means 10, 12, 14, end at 16. So it's missing something in the middle there. Let's see. So we've got the sigma notation here. Now that's probably the best sigma you'll ever see me write. Later on in life, they get to be a little bit more like that, but that's not too bad. And we want to go from k equals something to something. And it looks like we want to double k every time. So this would be like 2 times 1, and then this one would be 2 times 2, and this one would be 2 times 3. It looks like if k was 1, 2, 3, up to, what would the last k be? 8. It's because 2 times 8. So I think if we make k go from 1 to 8, and we just go 2 times the k each time, let's double check. If you put a 1 in, we get 2. Put a 2 in, we get 4. 3 in. If you put an 8 in, hot dog.
Right, and you can probably notice that these are sequences, right, with just addition symbols in between. So you can
Correct.
use the same analysis
Correct.
to use on
Correct.
sequences to find that rule.
Correct. Do you see any kind of how are these similar? Any connection
Everything looks
between
the
those
same
two?
except we've subtracted 1 from each term, right?
Yeah,
2
except
minus-
for the end one, right?
Yeah.
Yeah. So this is take away 1, take away 1, take away 1.
So could we try 2k minus 1 as our rule?
Okay. All right. Let's try it here. So k equals, and you wanted to go 2k take away 1 because this other problem you had 2k.
Right.
All right. And if you're old enough, you could do y2k, but our students won't remember
No, they
that.
won't.
All right.
Oh, yeah.
All right. So where do we start? What number do we want to start with? 2 times what number minus 1 is 1?
1.
1. And then does it work for 2 if we put a 2 in?
Yep.
Before minus 1 is 3. What's the last number have to be, sir?
I think it's got to be 9.
I think instead of 8, I think it has to be 9.
Yeah, you'd find
so
that
this
out
is going to
pretty
end at
quick.
9. So that's 18 minus 1 is 17.
Sweet.
All right. So in other words, if you want to generate odd numbers, use 2k minus 1 or 2k plus 1.
Right.
All right. That's a great way. And if you want to generate even numbers, it's just 2k.
Right.
All right. That's a good thing for later on in life here. Oh my, look at how are those, how do you get those numbers, sir?
These all look like perfect squares, I think. So 1,
Really?
4, 9. Is that right? 2 squares?
So,
4 squares?
so you're saying this is 1 squared, and this is 2 squared, and this is 3 squared, 4 squared, and then 9 squared?
Yeah.
All right, go for the sigma
squared.
notation, sir.
All right.
You got
Okay,
it.
so, oh, that's good.
Oh, that is horrible.
That's all right. So I think we're gonna start at 1. Oh,
Yeah. Dude, you are awful.
Okay. K equals 1, and what? So can I just square K?
What, does it work? 1 squared, 2 squared, 3 squared.
I think it works. So
I
we're
think
going
so.
up to K equals 9.
All right, so we end at 9 squared. That was, except for it being ugly, pretty good. Now, I did this on purpose. Do you notice what happens on the next one? They're just subtracting 1. So wouldn't it be, wouldn't that
Both
work?
are the same thing. Oh, yeah.
Wouldn't that work
Yeah.
for this one right
Yeah.
here? Yeah. Okay, now I usually offer a big bonus for this one if somebody can get that in my class. So pause the video, see if you can figure it out.
Try.
Now would be a good time. Give it a go. Did you pause? I don't think you paused. All right. So let's see. How do we get these numbers, sir? It starts with 1 and then a 2. So that's a 1. Then it's a 1 times a 2. And then a 6. Well, I see a pattern. A 1 times a 2 times a 3.
What is that?
And then a 24. A 1 times a 2 times a 3 times a 4.
How do I write? Wow.
You know what you do? Where's it end at? 1, 2, 3, 4, 5?
Yeah.
Okay, here's what it is. That would be 1 times 2 times 3 times 4 times 5. That's called 5 factorial. Did you like that?
Oh, that's what it is.
All right, 5 factorial. So I will write the sigma this time.
That's a really good sigma.
Now, yeah, compared to yours it is. So K equals, what did we decide? We'd start at, this is 1, then 2.
Yep.
And then
Because
3.
the last one was 5.
And then
Yeah.
4 factorial. So it's going to be 1 to 5. And then what is this going to be again?
Just K factorial. Right?
K with the factorial. Yeah, K factorial. Yay. Thanks for taking our class.